The Curity Identity Server brings identity and access management together with API security, enabling organizations and their users secure access to web and mobile applications. Curity is used to logging in millions of users every day. For a user, it's simple and they won't even notice. But we all know there's a lot more happening behind the scene to ensure secure and seamless login. And that's where Curity comes in. At Curity, we believe that industry standards are critical in order to ensure long-term, high-level security. The Curity Identity Server supports a wide range of identity and security-related standards, including OAuth and OpenID Connect. It handles the complexities of these standards, making them much easier to use, customize, and deploy without having to write any code. The Curity Identity Server has 3 core services that handles authentication, token management, and user management. The centralized authentication service provides a secure and flexible way to handle single sign-on and multi-factor authentication. That, coupled with the powerful authentication flow engine, enables many use cases such as account linking, adaptive authentication, name or attribute transformations, and more. The token service is highly configurable. Each flow can be customized with the type of token, how they are issued, what data is present, and more. This makes it possible to fully leverage the OAuth and OpenID Connect standards to achieve a token-based architecture. The user management service offers a standardized way to manage users and simplifies access to legacy data sources. You can integrate with any user repository or database, allowing developers to work with JSON over REST instead of SQL queries and LDAP operations. The Curity Login API is a hypermedia API that enables browserless login. This means developers will have full control of every step of the authentication flow and can create a very seamless experience for the end user. User login and authentication can be achieved without ever leaving the app, making it perfect for mobile and single-page applications. Deployment is extremely fast and easy. The Curity Identity Server can be deployed in any environment and fits easily into your CI/CD pipelines. It takes only a few minutes to deploy using ready-made Docker images, AWS AMIs, or an Azure ARM template. The provided Helm chart can set up an auto-scaling Kubernetes cluster with any cloud provider. In a cluster deployment, the system scales linearly. The cluster is typically deployed behind a reverse proxy, and each node can function independently of other nodes and even the admin node, since configurations are stored locally to the node itself. A more advanced setup involves setting up an asymmetric cluster where a cluster of sensitive nodes operate entirely independently from public or less sensitive nodes. The powerful system monitor and alarm function helps reduce downtime when issues are detected and lets you get on with solving the problem quickly. Alarms trigger an automated workflow that can send alerts to Slack, email, PagerDuty, or any other network operating center of choice. Now let's take a look at the Curity Identity Server. Here I have an instance deployed, and we can configure this. First aspect that I want to look at here is the base URL, which is the external URL that is used to contact this instance. I could set it here, but we're going to look at setting it using the provided shell that comes with the identity server. In the bin directory, I can start the shell when the identity server is running. Within the shell, I can switch to configure mode, meaning I can actually edit and make changes to the configuration. Set gives me a set of options for setting configurations, and I'm interested in doing this within the environment. And there's an option to set the base URL in here. I have one that I pasted in here. When I've set a configuration in the shell, I need to commit the change in order for the change to take effect. So with this committed, we can go back to the web UI, refresh the page, and our base URL in the system is set. Now let's continue to configure the different services within the system. Under the Profiles menu, we see that we can have multiple profile groups. This is a swim lane of services that can be configured. This can be leveraged for different environments and multi-tenancy purposes. For example, I have an authentication profile and a token service configured here. It's also possible to set up the user management profile. If we start with the authentication service, the menu on the left opens up where we have several of the settings for the authentication service. We start with the general. Here we can see that, for example, I have an SMS provider configured. It's using a Twilio SMS provider. That's actually configured under the facilities menu. So there's the Twilio SMS provider, and it's assigned to this authentication service profile. We also have the authenticators and authentication actions that we'll look at. Let's start with creating an authenticator. Click New Authenticator here. We have to give it a name. Here we can see all the authenticators available out of the box in the system. You have a standard HTML form authenticator, for example, a Duo, Facebook, Google. There's 30 plus authenticators available in total. Several are here out of the box in the product. Several are also available in our GitHub repository. When configuring an authenticator, we can have prerequisites and we can have actions that get triggered after the authenticator. We'll look at actions a little bit more later. Since this is essentially a username and password authenticator, we have to assign an account manager and a credential manager. Again, these are actually configured in the facilities menu. So I have a Postgres credential manager and a Postgres account manager, both of which point to a Postgres database or data source that I also have configured in the system. We have some other aspects that can be configured that we're just going to leave at default for now. When a change has been made to the system, we can validate the changes and we can look at the pending changes. This will show us what has been configured in the system but not yet committed. So these essentially shows the configurations we've made to the authenticator. In order for these to take effect, we have to commit the changes, and we can give a comment to that commit. And now if we look at the changes menu, it's cleared, and we can go in and review the history of committed changes to the system. Now let's take a look at Authentication Actions. These are configurations that can be added to create complex and advanced authentication workflows. There are several authentication actions in the system out of the box. I have added one here from our GitHub repository that is a debug attribute action. There are several time and date related actions, as well as geolocation actions like changed country, impossible journey. Additional actions could be creating a sequence. There's a JavaScript action. Let's create a multi-factor condition action to inject in our example scenario here. This will trigger an additional authenticator, and we first need to set a condition for this. I'm going to use the subject condition to look at the subject. We add a pattern to this where we can, for example, use any subject at curity.io would trigger this second factor. However, for demo purposes here, I'm going to trigger this second factor for any user. So we do a dot star in the pattern. Now, when we select the authenticator, we only have one configured in the system, which is our HTML one. So we have to go and create the second factor that we want to use for our action here. Go into Authenticators, and I'm going to create an SMS Authenticator. The SMS Authenticator is reasonably simple to configure here. I'm going to use the same account manager that we use for our HTML Authenticator. I'm going to select to send the one-time password as a code, and I'm not going to allow registration here since the user is already registered from our HTML Authenticator. Now that the SMS Authenticator is created, we can go back to our action and select SMS as the second factor. If we now look at the HTML Authenticator, we can add this action. We select our MultiFactor Action. So now we can see that we essentially chain this. So we have the HTML Authenticator that triggers the action. And for any user, it will trigger a second factor. Additional configurations can be made to the authentication service. Service providers, endpoints, account domains, protocols, and filters. We will not cover that in this demo recording. Instead, we're going to move on to the token service and take a look at how we create a client. I don't have any clients, so click New Client, give it a name. And so in a client, we configure a given client to have specific capabilities. I'm going to choose the code flow and the implicit flow for my client. You would typically create a separate client to, for example, do introspection and other types of flows. With this client, we need to configure the redirect URIs. I can add the ones for OAuth tools in here directly. This is where we would configure them appropriately if you have applications using this client. The authentication methods available for a client, I'm going to choose to use the secret with a password here. We next choose what authenticators we want to be allowed. We only need to choose the HTML authenticator here, since the SMS authenticator will be triggered from the action. With the capabilities configured, we can choose some of the OAuth and OpenID settings. I'm going to add the OpenID scope to my client. We can do other settings such as access token, time to live. We have our redirect URIs. And here's our authenticator that was already configured. This is all that's needed for a simple client. But let's look at adding an additional scope to our OpenID scope here. I'm going to create a new scope. We'll call it my scope. And save it, which adds it to the client. Let's also take a look at how we can create a custom claim that we can add to this new scope. So if we go to the claims menu, we can see that we have several claims already available in the system. Let's create a new claim and call it custom claim. This gives us a set of options, whether it's required, whether to expose it in the metadata. We can then select what source we want, the claim source. There's only one out of the box. Others can be configured. So with that, we can also set transformation or a mapping. So we can actually inject a little bit of code here to customize what the format of the claim is going to be. I'm going to do a static value in here so we can see that in the demo later. We then map the claim to different tokens or user info. I'm going to add it to the ID token and the user info. So now we have a custom claim created, but it's not mapped to our scope. So we need to go into scopes here where we have the new scope that I created. If we click that, we can see here that there are no claims mapped to this scope. We can set a time to live for this scope, but we're going to just add our custom claim to this scope. And that's it. We've created a custom claim. We've mapped it to a scope that we have configured for our client. So this is now a scope that we can request. We're gonna commit these changes into the system. Additional claims providers can be added to the system. This could be, for example, getting values from Salesforce or other types of data sources. You can also configure the different endpoints we use for authorization and token endpoint and introspection, for example. Now let's test our Authenticator, Action, and Client out using OAuth tools. First, I'm going to make sure that I have the system configured for discovery using WebFinger. And we can see here that it is enabled. Switching over to OAuth tools, our testing tool, we can now configure a new environment in here using ngrok as a reverse proxy, so I'm going to name it that. We can now use the URL of my reverse proxy and discover. The issuer will be discovered. We get the metadata URL that then populates all of our endpoints. Can then go in here and create the client. The secret has to add up, and we enable the code flow and implicit flow for this client, since that's how we configured it. If we look at the scopes and claims, we can see here that my scope is one of the supported, and this comes through the scope being exposed through the metadata. We can also see that the custom claim is available here. We can now switch to my ngrok environment and then start flow, where we select which flow that we want to execute. We're going to do the code flow here. The client we configured is now available through the drop-down, and we can choose what scopes we want to request. The client had OpenID and my scope, so we can select those two. We can select specific ACRs if we want to request a specific authenticator. There's a locale that can be selected. We can enforce or prompt for certain things, such as login. We can now run this flow, which will get us the HTML authenticator. I don't have any accounts in my system right now, so we're going to create an account through the HTML authenticator here, so we can fill out information for a user. I'm going to add a phone number in here for the purposes of the SMS Authenticator. If we create the account, it will create it in my Postgres database that was mapped to the HTML Authenticator. And we can now log in with the username and password we selected. This triggers the SMS authenticators, and I have a code on my phone here that we can enter into the OTP field to verify, and that has us authenticated. In OAuth tools, we have now received an authorization code. This is part of the code flow. We can now redeem this code for tokens. We can enable auto-redeem code, so in the future we can just one-click run the entire flow. We don't have to redeem the code separately. But if I now redeem the code, we can see here that we get 3 tokens. We get an access token, a refresh token, and an ID token. And if we look at the ID token, we can see that we have our custom claim with my claim value, which is the static value we configured for that claim. We get that claim because we requested my scope. The Curity Identity Server comes with a powerful alarms feature. When an alarm is triggered, it is automatically displayed in the web UI, but it's also possible to configure alarm handlers that would send alarms to, for example, PagerDuty, or through an email, or as a notification in Slack. You can also use the SDK to develop your own alarm handlers. When an alarm is triggered, you can filter it by specific nodes, and in the list of alarms you can see when it was updated, what severity it has, and what resource. In this case, it was a slow connection to a database. We can also click the alarm to get additional details of the issue. Here we can see a more detailed description of the issue, as well as suggested actions to take next. If we scroll down, we will also see a breakout of the impacted resources. This alarm was raised due to a slow connection to a database, and we can see other components that depend on that database in this breakout. This includes an authenticator that is using a Postgres account manager and credential manager. In addition to showing the alarm on the overview page, the components in the facilities menu will also indicate that an alarm has been raised for that specific component. You see here the database and a credential manager and the account manager that are affected. Even clicking a resource in the facilities menu will show and indicate that the alarm has been triggered for this specific component. In this case, the Curity Identity Server recovered from the event, detected that the connection is back to normal, and this clears the alarm. In the facilities menu, we no longer have any indications of alarms for different components, and we can see that the severity has changed to cleared. With this, we can select the alarm from the menu and purge it in order to delete it. The Curity Identity Server exposes Prometheus compliant metrics. Here the metrics are visualized using Grafana. We can see details on issued tokens, errors, if debug log entries are found. We can filter the data on last 30 minutes, last hour, and so forth. It also exposes CPU load, memory load, and various information and details about processing times for different types of data source queries, as well as HTTP requests. It also lists authentication details such as single sign-on rate, login rate, the number of issued tokens and revoked tokens. Version 5.3 of the Curity Identity Server added the DevOps Dashboard. This is a scaled down version of the administration UI that is targeting the DevOps team. It is possible to set permissions for the DevOps dashboard in such a way that specific development teams can only access clients that are related to their project. This allows them to manage these clients without having to contact the Curity administrator for assistance. It's also possible to create new clients. We can select a single page application here as an example, where we get into a configuration wizard. For this client, we have to define a redirect URI. We then get to select Authenticator to assign to this client. We can configure the scopes for this client. If we enable OpenID Connect and user info, it will automatically select the profile and OpenID scope for us. You can see here in the summary that no authentication is set to true, and require proof key is set to true. This is because we created a single page application where no authentication would be possible. We can see that the capability added is code flow. No authentication method is set. We scroll down and expand the advanced. We can see that require proof key is also enabled. We can also review scopes within the DevOps dashboard. We can create new scopes that could then be assigned to clients that we have permissions to manage within the dashboard. It is also possible to view claims. However, it's not possible to configure or manage claims at this point. Alarms are also available in the dashboard. We can see here a slow connection alarm for a database. Clicking an alarm will give us additional details just like it does in the admin UI, and we can see what resources that are affected by this alarm and more details. This concludes this demo recording. If you have any questions or feedback, you can always find us at info@curity.io or on Twitter @CurityIO. Thanks for watching.